Okay, YouTube, let's continue with the move generation that we started looking at yesterday, or last time, depending on when I released this video. So, this is where we were. We had made the basic structure of the generate moves function. We had fiddled around with some things, and if we look at the test here, it has a single knight at some location, kind of in the middle of the board. We make a game structure based on that position, and we generate the knight moves. So the generate knight moves function doesn't do anything yet, but it prints the attack, so we can see that we get the correct thing. So now we need to check any squares occupied by our own pieces. So we can say something like let own occupancy equal match piece.color, and if it's white, then have I imported color? I've not imported color, so let's just do it like that. Then it's game dot white occupancy, and we haven't defined this yet, but let's assume it's a bitmap of where the white pieces are. Same with that. And then attacks should be all the squares where there's none of your own pieces. So it should be something like this. So first we say everywhere there's not a white piece, and then we end it with the attacks. So I think that's more or less correct. So let's keep that one. Let's add another one down here. And then let's implement these two fields. So we need to go to the game file and the game struct. And it needs a white occupancy, black occupancy, and then we have to remember to add it down here where we initialize. So this will not be correct because we have to fill in these fields when we load the game, of course. But let's for now try to run the test and see if it works. So it did. Okay, use exclamation mark, and in the game initialization down here, we have something missing. Oops. Okay, fantastic. So I thought I fixed that. Right. Okay, there we go. Right. So the question is where we should fill in these things. So now I'm seeing we have this very nice function, push piece and square, and it would make a lot of sense to also fill in the occupancy here, I think. So let's say, first let's say we want a bitboard for the position, and I always forget this like index to position or something like that. No, it's never good when you forget how your own code works. And there's also something here where we have multiple type aliases for the same thing, but whatever. For now, it doesn't matter. Okay, maybe we don't have a function because we just need to do like this. Good. And now we say there could be a better way, but whatever. So if it's black, sure. Then black occupancy equals, or then you add the bitboard, and otherwise we add it to the white. Great, and those are not defined because we haven't done use color. Okay, now it works, but we don't have any tests for this, so we might as well add it. Test occupancy, start position. Do we have that? So we have the initialize. Yes. So we can say is this thing, right? Yes. And white occupancy is 0, and then for I in 0 to 16. And the same, more or less. But now it should go from 48 to 64. Okay, well, one of them failed, which is great. Failures, test occupancy start, test generate night move. So why is it even running test generate night moves? It shouldn't run that when I do this command. Is my Emacs crap still not working? Let's just try to put out the command so we can see. No. Okay. What's happening with this? There we go. Then this. Okay. Running 0 tests, so now it's broken again. And it's still still broken. Okay, split string. And then I also want car of the last. That should do that. Okay. Great, now it's finally running only the one I want. Then we can go back and remove this message. Okay, so the occupancy thing failed, and it said, you know, one thing that's kind of weird is that the error messages are just like in a random spot. And it's not put here or something right after, but whatever. So the left is 0, which means that the occupancy never gets set, which is weird. So push piece. Why isn't this? We agree that inside read fn we push a bunch of pieces somewhere. We don't. We never call this function, so that would explain it. Let's see. So it's only here it's happening. And what does this task row do? Task row. It returns a vector of pieces and a vector of squares. So we can just say position is piece dot position, and that is already a bitmap, so I can say match piece dot color black. Great. Now okay, whatever, just give me a reference then. Ah, I see. So, how about this? Okay, so now the occupancy is correct, at least for the initial position. Let's keep it the test for that as like that for now. And then if we run this test, there's no difference because there's only one knight. So let's make it a little bit more interesting. Let's say 2 knight 5. Great. So the point is now we added another knight, and it's actually obstructing the other knight, maybe we should do this. So here you see the two knights, and they're obstructing each other. So if I look at the possible moves for this guy, there's one missing. So far so good. And let's say enemy occupancy. And now we have to think about how we generate the new moves. So these that we have here are the possible moves. And then I want to loop through them and generate new games where or new positions where the knight is in that square instead. So we need to find some way to loop through this bitboard. Which, it's a little bit annoying. Let's go into utilities. And now I want a function called extract bits. So it shall give me a vector of usize, let's say. So basically it should turn this thing, for example, into like the 0 and 2, because the first bit is set to 1 and the 0th bit is set to 1 and the second bit is set to 1. And the way we can do that is, let's do that, and let's say while, so result, maybe there is a smarter way to do this. Okay, while bits is not 0, then next bit scan bits, result the push next bit, and then we should remove that bit, which we can do like this. Finally we return result. More or less correct, but let's test it. Test get bits. So input is 2, 5, 55, and output is it was get bits, right? No. What the fuck? Extract bits. Two, 5, 55. Run it. Did not work. Okay. Oh, it's some warning, I guess. Okay, that worked. So now we can say here do it up here. Potential moves is extract bits from attacks. It's not found because we haven't imported it. Okay. Great. So now we need to, for move and potential, for potential move and potential moves, let's okay, start by making a new game with the where the knight is moved. So new position is, now I really want clone. Let's hope that that exists. Seems like it does. So it's cloned, and then I want to say, then I want to say piece index is equal to new position squares it's kind of weird, isn't it? So pretty sure this won't work because the piece position is that, so I have to actually bit scan this guy, and then I can say the piece is piece index. Something is a little bit suspicious. Okay, be right back. Okay, so basically I want to say move piece, and which piece do I want to move? I want to move so I can like give the position, can give the reference to the piece. Okay, for now let's just say this, the piece at that position. I want to move it to this position. And I think that should be fine. So let's implement that. So mutable reference to self. We want the piece position, which happens to be bitboard, and we need the new position, which unfortunately is of a different type. So I wonder if there's a better way to do it. But for now, this we'll have to do. So first index into piece list, and then the piece. Whoops. And Then we want to say piece dot position equals new position. And we also want to update the square. So let's do this. Square index. And then we want to say self.squares square index equals to empty. And now we need to check the destination square. Check if destination square is occupied. And if it's empty, then there is no problem. We just make it occupied with square with the new position. If it is occupied, then we could check by a piece of the same color as piece. So let's say let other piece equal other index self.pieces.other index. Now we may have to have a bunch of like references added later, but whatever. If piece.color equals other piece.color, then we want to panic. Something like that. Otherwise, then we want to remove other piece from piece list and update the square. So let's do that. 1 second. Okay, so there is a remove function that we can call, so we can simply do pieces remove other index, and then we update the square self.squares in the new position. Should be occupied with the square index. So a little bit of complicated logic for sure, which means we need a test. And I'm going to actually have the function here, and then I will open the same buffer over here, and then I can refer it. So first we make the game, and it should be immutable. And then we say, let me move the piece at position 0. No, at position 1, or like this. let's move that to position 16, and then reprint it a couple of times. Just for now to check. Okay. And it failed in a couple of ways. Okay, so one square. Game piece cannot be indexed by game square. Okay. Okay, so Alright, so we have to say something like match. Actually, this is the square. So square, and then we have to say we want to find a piece index, and if the square is empty, then there's some kind of inconsistency because we think there's a piece at that position. So let's panic. Try to move a piece from an empty square, and if it's occupied by an index, then we return the index, and then we can say like so. Let's try to run that. Okay, now there's a bug over here. 73. What? Okay, whatever. Cannot move out of index of help. Consider borrowing here. Exactly. So we want a mutable borrow actually. That doesn't. Can I do this? Can I do this? Okay, so here it wants a mutable borrow, and then it complains down in this line. Okay. The infamous borrow checker problems. What would happen if I did this? It's a little bit. A little bit weird, but Okay. Some warnings and errors from the move generation file. And so do I have to dereference it first and then clone it? Can I do that? Okay, great. So let's try to make game clonable. Game. Square is clonable, piece is not clonable. I think it's fine to make it clonable. Piece type. That one's clonable. Let's go to, oops, stop. What am I doing? So let's go to knight attacks. Make that one clonable. Great. Why would it not be clonable? Okay, give me a second. So I think we should be able to do something like this. Implement clone for knight attacks. Clone, and what does the does Stack Overflow say? Knight attacks. I really thought you could clone a vector, but now it doesn't implement copy. That's great. Can I derive that? Cannot. Okay, so we also have another kind of problem, which is that there's no reason to be copying these things around. They're the same, they're static, they should never change. So perhaps that means we should make it like a global variable. But we won't look at that now. Now let's just get it to compile. Okay, now I have to look up the copy trait. Let's do that together. First, copy trait. Weird. Okay, I'm trying really hard to get this to work. Okay, 1 second. Okay, so a simple solution was just that we didn't need copy. And okay, so here we have our little test that's printing things. We have the start position, and then we move piece from position 0 to position 16, which is what happened, except that it turned into a pawn, which is very strange. How the hell did it turn into a pawn? I'm genuinely extremely confused. Okay, it says it's a rook here. And what does it say at the end of the function? It still says it's a rook. So maybe there's a... No, wait, so... No, that's correct. It's because it's a square index here. Okay, and it should say piece index. No? Huh. Okay, how does toString work? Not this one. Yeah, we loop over every square and then what's IDX? And then we look into the pieces. Okay. So what if I print? Whatever. Piece index. Okay, right, because it has to be square index. Actually, no, it has to be new position. Yeah. Great. So what is the new position? It's 16. And if we go to string on this, it's a rook, string. Okay, let me debug this off screen. Okay, I think I found the bug. So it says here, if the square is empty, we make a new position, but shouldn't, the index is not the new position, it's the piece index. So let me remove this debug stuff. Remove, thank you. And also this and this. Okay, so now it works. Amazing. And now let's just make some checks. So we want this thing. Want that to be empty. And we want this one to be occupied by the piece, 0th piece. Derive partial eq. Okay, this one failed. Okay. It's because this is like a different piece probably. I just assumed it was. There's a lot of annoying debug statements here I need to get rid of. Yeah, so the 0th piece is actually a black rook. So let's assume it's like 32, 24. Yes. Right, and then it's not the 24th piece, it's the 0th piece, it's the 24th piece. Okay, I think we will stop here for now, but basically now we have all of the main pieces. I think it's just, we just need to put these new positions into the result list. You know, return them from this function and write some more tests and restructure it a little bit so we don't have to clone the knight attacks and those things. Those should just be static fields. Okay, until next time.